Now there are some applications of using matrices. Now any three non-collinear points with distinct x-coordinates determine exactly one second-degree polynomial as illustrated in example 9. The graph of a second-degree polynomial is a parabola. Now in the past, what we've done is actually use the parabola formula or actually use our calculator to figure this out. Now what we know from these points, -1, 5, 2, -1, and 3, 13, we know that the function value of -1 is 5, f of 2 equals -1, and f of 3 equals 13. Now we're actually going to put it into the equation f of x equals ax squared plus bx plus c. Now for the first one, because x is -1, when you put -1 into ax squared plus bx plus c, -1 squared is 1, so we're left with a, minus b, because you put -1 in for x, you get a -b, plus c, that will equal 5. F of 2, 2 squared is 4, so I'll end up with 4a plus 2b plus c, that will equal -1. F of 3 will be 9a plus 3b plus c, and that will equal 13. Again, all of the values, -1, 2, and 3, those are x values. Now again, we're going to use pretty much the same method we used in example 8. We're going to create a coefficient matrix. We're going to multiply it by a, b, c, because those are variables. And it's going to equal 5, -1, and 13. So we're going to put these into our calculator. It is a 3 by 3 matrix, so let's enter that. And also edit matrix B right away. This again is a 3 by 1. Let's find the determinant of matrix A. Determinant is -12, so A inverse exists. So again, let's find A inverse times B. That'll be 4, -6, -5. So those are our values for A, B, and C. Plugging these in to ax squared plus bx plus c, f of x will equal 4x squared minus 6x minus 5. Here's our equation. Now to check that, to make sure everything's kosher, and make sure these points actually fit, put this into y equals 4x squared minus 6x minus 5. Our window we can make -5 to 5. This window we can make -10 to 20. When we graph it, we get a parabola that looks just like this. Now let's find some values. We have a value at x equals -1. The value there is 5. F of -1 is 5. F of 2 is -1. F of 2 is -1. It fits on our graph. F of 3 is 13. f of 3 is 13. So this equation, 4x squared minus 6x minus 5, is the equation that we want it to be. Moving on to example B. We're going to use the same process here. F of negative 1 does equal 3. F of 1 equals negative 3. F of 2 equals 0. So going through here, remember it's ax squared plus bx plus c. So f of negative 1, so x is negative 1 here, we'll get positive a minus b plus c equals 3. F of 1 will be a plus b plus c equals negative 3. And f of 2 will be 4a plus 2b plus c equals 0. Putting this into our matrix here, we'll have 1, negative 1, 1, 1, 1, 1, 4, 2, and 1. We're going to multiply it by a, b, c, and that will actually equal 3, negative 3, and 0. So we're going to put this into our calculators. Edit my 3 by 3 matrix. We're also going to edit the 3 by 1 matrix. Let's find the determinant of matrix A. That's negative 6, so A inverse does exist. Let's multiply matrix A inverse times matrix B. You get 2, negative 3, 2. Which means my equation, f of x, will equal 2x squared minus 3x plus 2. Again, let's just check to make sure that all the points are in there. I'm going to find values here. F of negative 1 is incorrect here. It should be 7. I think I must have put something. I think I might have put a wrong number in here. This should be a negative 2 here, which means this will be a negative 2 here. My mistake. Not reading the calculator correctly. Let's try this again. That should be a minus 2. Again, let's find the value here. X is negative 1. You should get 3. X is 1. You do get negative 3. X is 2. You do get 0. That now is your correct answer.